Hey guys, it's Miss Fele. We're going to be looking at today's lesson, which is operations of rational expressions. Now, I asked you all this weekend, well, I asked you Friday, to look at the video on simplifying rational expressions, and I'm kind of going to do a deep dive on the PowerPoint that's also linked under day one. Now, as I said before, each of these days we'll have a video. Certain days we'll have face-to-face conference where you can ask questions. Along with the video, you have to complete the daily assignment or you will receive a 0, and it has to be done every single day. Okay, it's not going to be long, 5 or 6 questions per day, but you have to make sure that you do those daily so you can receive a score for it. So today we're talking about rational expressions, and a rational expression, guys, is nothing more than a fraction that happens to have variables in it. So we know operations of fractions, we know how to factor, we've been working on those two things. And now we're going to put them together. So here's an example of rational expressions. Notice that we've got like 4 over 3x, x minus 8 over x plus 3. Everything is written like a fraction, and some of these fractions can be factored. One super important thing, a denominator of any fraction cannot equal 0. So we do have to think what values for x here could make that 0. And these are known as restrictions. We have restrictions on the variables because we technically don't know what they are. So every time you see a problem like this, you want to kind of consider, all right, what can x not be? In a situation like this one, if 3x can't equal 0, then I can follow up with, cool, x can't be 0 in that particular problem. Notice in the second one though, 0 is not an issue there, right? There's a different restriction on this one. So we got to set up another problem. We would say x plus 3. That cannot equal 0. Minus 3, minus 3. Cool. That means in that problem, x can't be negative 3. Now this last one looks like a doozy, but it's not that bad. Mainly because it's not factored. That's why it's looking a little challenging. But we know how to factor it. Showed you guys how to do the x method with factoring. 2 numbers to multiply to be negative 9, add to be 5. So nothing's actually coming to mind. That means this one is not factorable, so we wouldn't even have to say anything about restrictions for that one. All right, oops, sorry. We're going to jump right in with simplifying rational expressions. Now, simplifying a rational expression is nothing more than making the fraction simplified. I'll give you a basic example, and we'll jump into this example here. If we had 6 over 14, and we wanted to simplify this, everybody knows what the answer is going to end up being. We all know that the answer is going to end up being 3/7, but let's talk about why it's 3/7. Technically, 6 factored would be 2 times 3. I'm sorry, not 3/7. Oh no, that's right, 3/7, excuse me. And 14 would be 2 times 7. We should notice, hey, 2 over 2 is just 1. So they would cancel each other out because they're the same exact factor divided by each other, leaving us with just 3 over 7. So we're going to do that same thing with our rational expressions here. We immediately are going to factor first. That is step 1. Factor, factor, factor. That's actually going to be step 1 in every single thing we do for this unit. Step 1 will be to factor. So if you are in my class and you've been keeping up with your note cards, this is an excellent note card to have. Simplifying rational expressions. So step 1 is going to be factor. So I'm looking at my 7x minus 7, and the numerator I know has a GCF. So I want to factor that out. So the GCF is 7, and it leaves me with x minus 1. That one's pretty easy. This one down here is a difference of squares. It's 2 perfect squares, so it factors out to be x plus 1 times x minus 1. Check it out. We've got a common factor of x minus 1, so we can get rid of that, leaving us with 7 over x plus 1. Now, as I said in the previous slide, we have to say the things that x cannot be. X cannot be. So we had 2 factors, x plus 1, x minus 1, only in the denominator. Something I should have said earlier. Restrictions can only be found in the denominator. So I'm going to say this factor of x plus 1, I don't want that to be 0. And I also don't want my other factor of x minus 1 to equal 0. So that means that x cannot equal -1. And this one over here means that x cannot equal +1 because we just add 1, -1, -1. So you see our restrictions, we're going to throw those in here in our answer. So, oops, not a good circle. This is our final answer. The simplified fraction would be 7 over x plus 1 when x cannot equal +1 nor x can equal -1. Oops, positive and -1. All right. So, and if you're looking at the PowerPoint, I am going to walk through it through the PowerPoint, but I would kind of like to rewrite it and show what I'm doing step by step so you guys can understand it a little bit better. We're actually going to skip this question. I want to go to another one. Skip. All right, so here's something that I want you to try on your own, and I'm actually going to do number 2, and you guys can do number 1. So in problem number 2, notice we again have a GCF for the factoring. Always factor first. So the GCF here is 5x squared. They both have 5x squared, and it leaves us with, let's see, 5x squared times 1x. That would give us the 5x to the third, and then 2 times 5x squared would give us our 10x squared. So that one's factored. This one down here actually can be factored twice. It does have a GCF, but after we take out the GCF, check it out, we still have a factorable quadratic. So we can do the x method. 2 things to multiply to be -16, add to be -6. Multiplies to be -16, adds to be -6. Those 2 things are -8, +2. So the factors come out to be real easy. X minus 8, x plus 2. Same. Eliminate those. So the answer is 5x squared over x minus 8. But again, x cannot be. What would make x minus 8 turn into 0? Well, if x was 8. So that's a limit, that's a restriction. And then for the x plus 2, x cannot be -2. You might be noticing that the signs are just changing. And that's kind of sort of how it works. All right, try number 1. See if you can't factor it and simplify it. All right, now let's go to multiplication. And again, I want to skip a couple of them. Here's a good multiplication problem. It looks like it is really difficult, but I'm telling you, our steps are simple. We have to first factor. Second, we would cancel like factors. And we're going to wrap it up with simplify. It's going to be really easy, I promise. Stay with me. So the numerator, right? We got 2x squared plus 5x minus 7. We're definitely going to x method that since the first step is factor. We need 2 things multiplied to be -7. Excuse me, multiplied to be -14. Add to be +5. That one's easy. 14 has 2 and 7. But I need my 7 to be the one that is positive, my 2 to be negative. Yeah, remember how we do it. We divide both sides by the leading term of 2. Oh, sorry. There should be a 2x. I don't know what I'm doing today. We should have had a 2x on top right from the beginning. 2x, and again, +7, -2. Notice that that simplifies down to be x over -1. So one of the factors up top, and I'm just going to rewrite it down here, is just going to be x minus 1. Real simple. The other factor, this one here, is going to end up being 2x plus 7. Now the denominator, the x plus 4, we can't do anything with that. It's a factor. We'll just leave it like that. Times this one right here, we got a GCF of x. So I'm going to take that GCF out. It leaves me with x plus 4. And the denominator, I can do the x method for that one as well. 2 things to multiply to be 1, add to be -2. It's going to be -1 and -1. And since the leading coefficient is 1x, this will be easy. X minus 1 times x minus 1. So we got it all factored. It's looking good, right? Cancel everything that is alike. Now the rule is to cancel a factor has to be at the top and the bottom. At the top and the bottom. Notice I didn't get rid of all 3 x minus 1s because there wasn't a pair for everybody. It has to be top and bottom only. The last step says simplify, and simplify is the easiest step. We're just writing what's left over in the numerator. X, 2x plus 7, right? In the denominator, we've got 1 of the x minus 1s. Okay, that's the simplified rational expression, but we got to talk about what can x not be. Now, remember what I said. We're only looking at the denominator. So one of the denominators was x plus 4. So the restriction on that is x cannot be negative 4. The other denominator had the same exact factor. So it's going to give you the same exact restriction. X can't be 1. So I'm going to say x can't be negative 4. X cannot be 1. I'm always, ta-da, voila. Click, 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 click. All right, so let's do one more. Whew. This one again looks like a doozy, but I know you have it. The numerator factors out with the GCF of x squared, leaving us with x plus 3. The denominator, if I did the x method, I'm looking for two things to multiply, be negative 6, add to be 5, negative 6, 5. That's going to be positive 6, negative 1. The leading coefficient is x squared, so that one's easy. X plus 6, x minus 1 times. Over here, we again got a leading coefficient of 1 x squared. Those with the 1 x squared, y'all, is really easy. You don't even technically have to do the x on top. It's just going to end up being whatever two numbers you come up with. And in our case, two things to multiply to be positive 9 and add to be negative 10 have to both be negative. So we got x minus 9, x minus 1. And then in the denominator, two things to multiply to be negative 27, add to be negative 6. Those two things are going to be, help me out, what is it, y'all? It's going to be x minus 9 and x plus 3, right? Check me now. Y'all send me an email if I'm wrong. And again, we can swipe, cancel. Get rid of it, get rid of. Top and bottom's the same. Exit out. Top and bottom's the same. X minus 1, x minus 1. Top and bottom's the same. So we simplify it. The only thing that's left in the numerator is this x squared. Only thing that's left in the denominator is this x plus 6. But the things that x cannot be are, x cannot be negative 6 because of the x plus 6. X cannot be positive 1 because of the denominator is x minus 1. X cannot be 9. And x cannot be negative 3. We do not ever take restrictions from the numerator. And that is multiplying. At any time throughout the video, if you need to stop, sorry, it looks crazy now. If you ever need to stop the video, please be my guest. Go ahead and do that, okay? Now, division of fractions is so similar to multiplying them. As you can see from the, let me go back a smidge. As you guys can see from the example, the numerical example, when we multiply, we do same, change, flip, keep, change, right? So we're going to do that same thing with our rational expressions. Okay, so here is our rational expression problem. Now, I am still following the rules. Step 1, factor. Now, step 2 is actually going to be keep, change, flip. This only is for division, ladies and gentlemen. Step 3. Step 4, that's a 4 by the way. Step 4 will be to simplify again. We're always going to include our restrictions though. Okay, now I will say I messed up on the PowerPoint. The PowerPoint actually starts off the flip as before it does the factoring, and I do not want you to do that. I promise you, trust me on this one, it'll be so much easier if you factor the whole thing first. Okay, so we know how to factor. We're going to factor this one down here. This one will be y plus 12, y minus 2, because we're factoring gurus. This one will be like y times y plus 2, because that has a g. And this one down here will say y plus 4, y plus 4 times y minus 2. Now, the reason why we want to factor first is because we need restrictions. Remember what I said. Restrictions are going to be found in every single factor that ever touches that denominator. So far we got a restriction here. Y can't be negative 12. Here, y can't be 2. Here, y can't be negative 4. And we already said y can be 2, so we're not going to say it twice. If we were to flip that first, we would miss the y can't be negative 4. So it's so important to factor before you do anything else, okay? Excuse me. Super important to do that first. All right, let's move on in the problem. So after we factor, everybody, right? We got to flip it. Oops, maybe not. Oh, yeah. We flip it and change it to be multiplication. Now, actually, I'm going to do it by hand. So let's go back a smidge. Previous. So we factored all of our terms, and we're going to flip those factors. So y'all saw the factors on the first page. I'm actually going to show what it looks like when it becomes flipped. Y plus 12, y minus 2. Now remember, it's same change. We have to change this to multiplication. And flip. That means that these are going to switch places. Their factors will switch places. So the top factor will now say y plus 4. Y as a rule, keep change flip. We're on the flip step right now. And y times y plus 2. Check it out. We got some new restrictions. I'm just going to go ahead and start including restrictions, man. Y can't be negative 12, positive 2. We said it couldn't be negative 4 because of this factor that was at the bottom initially. Oh, we got some new ones. Y can't be 0. And y can't be negative 2. We're always going to have to include restrictions. So the moment you get some factors in your denominator, go ahead and start listing them at the end. And we also have some things we can cancel. So y plus 2 at the bottom, there's a y plus 2 at the top. Y minus 2 at the bottom, y minus 2 at the top. Nothing else. So the only thing that's left in the numerator is y plus 4 over y plus 12 times y. Can't forget that one, right? Those are the only two left in the denominator. And all of these wonderful restrictions are also a part of our answer. They go hand in hand. They must be together. Okay? So, as we're doing any of the operations with rational expressions, we want to recognize, again, ladies and gentlemen, factor first. Please. Factor first. Factor them first. These two problems are kind of a try your own problem. The answers for them are right there. So I would like you to try them out just to see if you got the hang of it. Remember that you're always factoring first. I am going to also be seeing you guys. Oh, let's discard that. I'll be talking to you a little bit later about how we're going to proceed with face-to-face contact. So, you guys have a great day. Bye.